4.2, talking about congruence in triangles. 4.2 is talking about congruence in triangles. First thing, we're talking about congruent figures. Now, we've talked about congruent segments and angles. The congruent figures are something different. All right, that means they have the exact same size and they have the exact same angle measurements. So the corresponding angle measurements are the same and the corresponding side lengths are the same. Congruent figures. Now, more specifically, we're talking about congruent triangles, but congruent figures is where we're starting today. Corresponding angles, when two figures are congruent, the angles that are in the corresponding positions must be congruent also. Same with the sides. The corresponding sides need to be congruent with each other. Now, realize figures can be rotated and flipped around, but the corresponding sides have to match up, and we'll talk about that more specifically just in a second. For example, here, I've got two figures, and I look at them. ABC and triangle RQP. Look, it's got one congruent mark. This one has one congruent mark. This one has two congruent marks. This one has two congruent marks. This one has three congruent marks. Three congruent marks. Look at the angles. One arc, one arc. Two arcs, two arcs. Three arcs, three arcs. So you know that these angles are, or excuse me, these figures, these triangles, are congruent. We want to write a congruent statement. Okay? A congruent statement means you name the figure, triangle ABC. You write the congruent symbol, and then you have to write it in a specific order. Okay? You can start anywhere in the first one, but that second one has to be triangle and the corresponding part to A. Okay, what angle corresponds with A on the other figure? R. Okay, so somebody said P and somebody said R. Well, A has how many marks? Three. So P has 3 marks. Good. Now, if I went from A to B goes from 3 arcs to 2 arcs and 3 markings between, right? So the next one would be Q, and then the last one has to be R. Order matters. Anytime I write a congruent statement, I can automatically tell what angles are congruent and what segments are congruent. Okay? Because of the congruent statement. So, when I want to identify the parts, I talk about angles. We said angle A is congruent with what angle? Angle P. Do you see it? You can write it from the congruent statement. You don't even need a picture. Angle B is congruent with what angle? And angle C is congruent with what angle? R. Is that all right? What if I move over and I do sides? Okay, so the side AB is congruent with what side? PQ. Everybody see it? Because of the congruent statement, I can automatically know that PQ and AB had the same length. BC is congruent with what angle? Or excuse me, side. Yeah, QR. And what's the last side? Good. Most people miss that because it's just written differently. But AC is congruent with PR. Realize no matter what shape you have to name all the segments. So if it's 4-sided, you have 4 segments that are congruent to each other. Any questions on that part? Okay, moving on. That. All right, so the next one, in example 2, we have quadrilateral, DEFG, and it is congruent, and it's an equal sign with a little squiggly above it, to the quadrilateral KLMN. We need to find the value of X. So first thing you want to do is find x on your graph, or your pictures. And x is this side length right here. That's the only one that has x. So I'm looking at NM. NM. What's its corresponding side? No. Look at your congruent statement. What's in the same location as FG? All right. So if these are congruent, congruent means they're what? The same. And same means that they are equal. And if they're equal, you set them what to each other? Equal to each other. So 5x plus 2 equals 12. Subtract the 2 from both sides. 5x equals 10. Divide by 5 to both sides. X is 2. That's part A. Part B asked me to find the value of y. So now we've got to look for y. Y is the angle L. All right, so what corresponds with the angle L? I hear E and D. Which one in the congruent statement is the second term? E. Okay, you have to look at the congruent statement. Don't look at the picture because there's not anything that's matching on your picture. You have to use the congruent statement. All right, so they're congruent. They're equal. If they're equal, we set them what to each other? Equal to each other. So you got 5y plus 6 equals 111. Subtract the 6 from both sides. So 5y equals 105, and divide by 5. Okay, so be careful. It may ask you for the y, it may ask you for the x, it may ask you for the final answer. Just be careful what it's asking. Something nice to know is when you know two sets of corresponding angles are congruent, you can automatically assume the third is also. So we know that angle C has to be congruent with angle F, even though it's not marked. Remember, all three angles add up to be 180. If these are the same and you subtract them from 180, C has to equal F. So that's a nice thing to remember to do. All right, again, this picture, there's not a marking on a W, okay? But we know, because this is 1 mark and Z is 1 mark, and 67 is 2 marks, and Y is 2 marks, all right? I know that all three angles add up to be 180, right? So I can do 180 equals 54 plus 67 plus whatever the measure of angle W is. All right, so can I add 54 and 67? All right. You get what? 121 plus the measure of angle W. Oops. And you subtract it. And you should get 59. Okay. 59 equals the measure of angle W. So now I have W. But W and X are the same, right? So that means that you set them equal to each other. Very good. Add 5 to both sides. 64 equals 4x. And you divide by 4. And x equals 16. Is that okay? Okay, the next one. We're going to determine whether the triangles are congruent. All right, so we're looking to see, is there enough information to determine if the triangles are congruent? And if so, then we got to justify our answer. So, in order for them to be congruent, all sides have to be congruent, right? Corresponding sides, and all angles. All right, so I've got the markings. There's a 1 mark, 1 congruent mark, 2 congruent marks, 2 congruent marks, 3 congruent marks, and 3 congruent marks. So the sides are good. So I can say that. You want to use corresponding, but all corresponding sides. And if you were more specific, you could write out the segment DF is congruent with the segment FH. That's fine. But all corresponding sides are congruent. Now we've got to look at angles. I'm sorry? That's true. So now we have to look at our angles. We know that angle D is congruent with what angle? H. What about angle DFE? Okay, remember DFE is this angle right here. What is it congruent to? Is it? GFH. Why did you think it was congruent with angle GFH? Good. These are vertical angles. Anytime you see vertical angles, I would go ahead and mark them as being congruent. Okay, so we know that they're congruent because they're vertical angles. All right, now that I have 2 sets of corresponding angles that are congruent, what do I know about that third one? Angle E and angle, not H, but G are congruent. Okay? Be careful. It is congruent. Let's write a congruent statement. So my congruent statement, pick the first triangle, triangle DEF, is congruent with triangle. Now what's the angle the same as B? H. All right, then we went from D to E. So D to E, 1 marking. H to what gives me 1 marking? To G. And then F is left over. So there's my congruent statement. Order matters. If you write it incorrectly, it's wrong, and that's a huge part of the test. Nice properties to remember are the reflexive property. It means it's congruent to itself. All right. Triangle ABC is congruent to triangle ABC. Symmetric property, it may be written like this. Triangle ABC is congruent with triangle DEF. Symmetric property means just to flip it around. Triangle DEF is congruent with triangle ABC. Okay, that's all it's saying. Just you can flip it around. Now we've talked about the transitive property before. The transitive property takes 2 pieces of information and combines them. In other words, if I know that 2 triangles are congruent, and one of those triangles is congruent with a different triangle, then the first one and the last one are also going to be congruent. Think about it. If I have a triangle ABC and it's congruent to the triangle DEF, and that same triangle DEF is congruent to triangle JKL, and I know also that triangle ABC is congruent to JKL. Very good. Make sense? Yeah, you just had 3 triangles that are congruent. You just had to logically think through that. All right, last 2 problems on this section, which we're covering multiple sections. All right, so we want to find X. Look at your problem and see where X is located. X is that angle K. Okay? X is angle K. So I've got to find the angle that matches angle K. Which would that be? It has to be C. But I don't have any information on C. Can I find it? Yeah. Good. So the measure of angle C, right, is the 180 minus those other two angles added together, right? The measure of angle C is 48. You've told me before if C and K are the same, they're congruent, so they're equal, and you set them equal to each other. And then you solve for x. Add 2 to both sides. You get 50 equals 5x. We have 5 times x. The opposite of multiplying is dividing, so divide both sides by 5. 10 equals x. Any questions on how to set that up? Okay. Part 2. Decide whether triangles are congruent and justify your answer. So would these triangles be congruent? Why? Okay, all the corresponding sides are congruent. So she said that. All corresponding sides that is true. But now we got to look to see, are all corresponding angles congruent? Well, we know that D and X, they match, right? Anything else match? E and Y because they're both 90. Very good. And good. Because those two are congruent with another one, the last ones also have to be congruent. So that is true. Okay, if it asks you to give you specifics, then that means you have to name angle D is congruent with angle X, angle F is congruent with angle Z, and so on. But I'm not making you do that unless it asks for specifics of the parts of the angles. But justifying, you can just tell me that all the corresponding sides are congruent, all the corresponding angles. Be careful, because sometimes it does not match up. Right? Sometimes there's a not possible. So you have to really check to make sure. All right, next section. We are doing multiple sections, yes. Yes. All right, these are fairly quick. Congruent triangles using SSS, SAS, ASA, and AAS. This is ways to prove that triangles are congruent. All right, so sometimes not all the angles and not all the sides are given to you. Okay? In the section 4.2, they are. They are or they're not. The next section, you can use these 4 things to decide whether or not triangles are congruent. Okay? These are only with triangles. The corresponding angles and the corresponding sides work with any figure. This only works with triangles. So be careful. Make sure you can only do this with triangles. And of course, congruent triangles, corresponding angles are congruent, corresponding sides are congruent. There's a congruent statement, and you're going to have to do that on your homework. Order does matter. Not the first one, but the matching information has to line up. And there's just another example of congruent angles and congruent sides. So in example 1, there's no picture. I just know I have a triangle, UVW, and it's congruent to the triangle GHI. All right? So if I wanted to rewrite my congruent statement, right there it is. So because of my congruent statement, I can find answers. The measure of angle V is 90, and the measure of angle H is 3x plus 15. What do we know about V and H? They're equal because they're in the same location. So 90 equals 3x plus 15. Subtract 15 from both sides, keeping your equation equal. Bring down your 75 equals 3x. Divide by 3 to both sides. 25 equals x. So make sure you look at the bold print on your homework because it has congruent statements a lot of times in those. And that's how you find your answers. All right, a way to prove that triangles are congruent. All right, if you're given all three sides, none of the angles are given, but all three sides are. If all three sides, corresponding parts are congruent, side, 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 then you know the triangles can be congruent. Something nice to know, side, side, side. You'll need to know that for your test because you'll have to justify. And what do you justify saying side, side, side? All the corresponding sides are congruent, so therefore the triangles are congruent. And again, your congruent statement, order matters. All right. Remember, this is just a nice piece of information to remember. Triangles are more, maintain their shape better than a square. That's why a lot of times, bridges are made with triangle pieces, as it holds its shape better so you don't bend. Another term that you need to know is called the included angle, and that is the angle between the two sides. The included angle is the angle between two sides. All right, so in the theorem of side, angle, side, the side, an included angle, and a side. So if I'm given two triangles, and I'm given a side, the included angle, so the angle that connects that side and the next side, and I get the same thing over here, matching side, that included angle, matching other side. If that occurs, and only if that occurs, can I say the triangles are congruent? Yes. Yes. Okay? Only if that occurs, though. It has to be the included angle. If it's an angle over here, you cannot say that. Okay? It just doesn't work. Not necessarily has to be. Yeah. If I had what?
If you did angle AC and CB, it wouldn't work.
Okay, I'm not sure what you're saying about AC angle, because there's not an AC angle.
If you had AC,
Okay.
and BC,
Okay.
would that work?
No.
Why?
It's just is not a way to prove it. Okay. It may or may not, but we can't say for every time it works. Okay. It has to be the included angle. All right. Also, it's the included side. Okay. There's another term you need to know. Included side. I'm going to use that in just a second. So in example 2, we want to prove that these triangles are congruent. All right. What do we know about angle 1 and angle 2?
They are vertical.
They're vertical angles, and vertical angles are always equal. They're always congruent. All right. Now I'm given a side, an included angle, and a side. Over here I'm given a side, an included angle, and a side. That's side, angle, side. Is that one of my choices that I can use? Good. So I have side, angle, side. Remember the congruent statements. You're going to have to write them. Order matters. SYT. SYT should be WYX. Make sure when you have to write your congruent statements, order matters. All right, and that's all I had to do for proof.
That's all you have to write.
That's all you have to write. On this one, can I prove it? Okay, be careful. As long as they are the same, this one is, side, angle, side, they both have to match. One of them could be a side, angle, side. The other one could be an angle, angle, side, and it would not match. All right, if they do not match, they're not the exact same thing, you cannot use it. You cannot assume. All right, so angle, side, angle, your included side, your angle. Meaning this, you've got an angle. You've got the side that connects the next angle. Okay? They have to match. Now, these can be rotated around, but that's what you've got to have. Angle, side, angle. Angle, side, angle. Now, non-included sides are the ones that are not beside it. This is the only different one. It's called angle, angle, side. So if you have an angle, another angle, and then a side, okay? And they're kind of hard to recognize, so you have to be careful. Angle, angle, side, you can also prove that it's congruent. Okay, last one, and this is different. This only works with right triangles. If it's not a right triangle, you cannot use this. And sometimes in right triangles, you don't need to use it. Okay, but if it's a right triangle, check it out. It's called HL. It's called hypotenuse leg, and it means this. You've got your legs marked, and you've got a hypotenuse marked. And it has to be a 90-degree angle. If it's not a 90-degree angle, it will not work. Let me say no. All right. So in example 1, I want to know, is it possible? And sometimes it's not. Is it possible for triangles to be congruent? And again, for it to be congruent, both triangles must have the exact same reasoning, proof. Okay? So let's look. The only thing that I know is that they're right triangles, right?
Yeah.
Do they share any side? They don't? Okay, they share one side. Do they have any other angles that are congruent? No. So if they share a side, go ahead and mark it because it helps you out. All right. So now I've got a right triangle and I've only got a leg. Do you have anything else?
The base.
Okay, what about the base?
It is, it's a perpendicular.
Okay, it's perpendicular, so we know that these are 90. So now we have 90 degrees on both of them, and we know that they share a leg. Okay, so where's the hypotenuse? Are they the same? Okay, they don't tell me this. Guys, they don't tell me that they're the same. They don't tell me that anything bisects. So therefore, I can't tell, and so it is not possible. And guys, some on your homework, you're going to have some problems that they look like they're possible, but they don't match each other. So beware of that. All right, part B. Do they share any sides?
Yeah.
Okay, so go ahead and mark it. All right, do they have any other angles that I need to mark? Okay, what else matches? Well, the PRQ and the SQR match, right? And that's already there, so we don't have to add any more. Can I use any, there's nothing else I can add, nothing vertical angles or anything to mark. So I have an angle, you said, a side that is shared, and then an angle. So that's an angle, side, angle. Does that work? Okay, so let's make sure the other one matches it. Angle, side, angle. Yes. So it's an ASA. And then I want to write a congruent statement. So triangle PQR is congruent. Now what's congruent with P? Okay, S. And so I went from P to Q. So from no marking to 2 markings. S from no markings to R. And it's 2. And then I've got Q left over. So there's my congruent statement. Okay, last one. On this one, given R is the midpoint of QS. What does midpoint mean? What's equal? It's not the vertical. What's midpoint mean? She said midpoint means equal, that something's equal.
It has a point in both triangles or both angles.
Okay, it's in between 2 points. Now what's midpoint mean though? It's in the middle of those 2 points. All right, what else do we know? When it's in the middle, what do we know about QR? Good. So QR and RS are equal, and I get to mark that.
Angle Q and angle S are both 90 degrees.
Good. So angle Q and angle S are both 90 degrees, and angle QRP and angle SRT are the same. Where's the hypotenuse marked? Is it marked? Do they tell me that they're equal? So no, I can't send that.
It'd be ASA because angle.
Angle, included side, angle. Very good. So he's right. It's an angle, side angle. And remember your congruent statement? QRP, QRP, SRT. Yep. Order matters. That's it.